All right, middles, here's your problem today. It says find two fractions that are equivalent to 1/4. Well, remember, all week we've been talking about fraction strips. So we're using visual models to represent our fractions. And we've had one word that stuck out all week. Do you remember what it is? That's right, it's the word equivalent. And what does it mean to be equivalent? That's right, equivalent means equal or the same. And when we look at our fraction strips, we want them all to line up, and that's what we're going to use our dotted line here for. And so the fraction that we're representing today is 1/4. So we are going to look at 1/4 on our side of our fraction strips. Now, here's our 1/4. And yesterday, I taught you guys a strategy for figuring out how to find fractions that are equivalent to 1/4. Does anyone remember what it was? That's right. We can find fractions equivalent to 1/4 by looking at the multiples of 4. Remember, multiples are the answers or the product that you get when you multiply 4 times 1, 4 times 2, 4 times 3, 4 times 4, and so on and so forth. So let's do that together. Can someone tell me what the first 4 multiples of 4 are? Did you say 4, 8, 12, and 16? If you did, you're absolutely correct. Well, now that we know what the multiples of 4 are, how can we use this to help us out? That's right. The multiples become our denominators. So they are going to tell us which fraction strips we're going to select. And so since 1/4 was our first number, we've already used 4 as a denominator. So which one is next? That's right, it's 8. And so we're going to use the 8th strips. So we need to determine how many 8s will make something that is equivalent to 1/4. And we know that they're equivalent when our bars line up perfectly. So let's count. 1/8, 2/8. Looks like our bars are in line. This tells us that 1/4 is equivalent to 2/8. All right, you try the next one. Well, what was our next multiple of 4? That's right, it was 12. So that tells us that the denominator of our next fraction will be 12. Which fraction strip should we use? That's right, we're going to use the 12 pieces. And we need to figure out how many of them we need in order to get a bar that is the exact same length as our 4th and our 2/8. Let's count. 1/12, 2/12, 3/12. This tells us that 3/12 is equivalent to 1/4 and 2/8. Now, I only asked you to identify 2 equivalent fractions, but I bet you can tell me what the 4th one is as well. To start, how do we know what fraction strip we should use? Did you say we're going to use 16? You're absolutely correct. And so if we use the 16ths as our next strip, do you have a way to tell me what our next equivalent fraction is based on the pattern? Let me circle the numerators and see if it helps you out. Take a look. Do you see a pattern between the numerators? Did you notice that the numerator of the first fraction was 1, the second was 2, and the third was 3? And so what do you think the numerator of the next equivalent fraction will be? That's right, it should be 4, and the denominator should be 16. So let's see if we pull 4/16, if it will give us a set of tiles that are equivalent to 1/4, 2/8, and 3/12. Oh wow, it absolutely does. Great job, middles. You did a phenomenal job today. All right, senior scholars, here's your problem of the day. So all week we have been multiplying a double-digit number by a single-digit number. So today we're going to up the ante and we're going to multiply a double-digit number by a double-digit number. But we are still going to utilize our area model. So remember, When we're multiplying using the area model, we always start by writing both of our numbers in expanded form. And because we now have two double-digit numbers, we have to expand them both. So let's start with 25. What is the number 25 if you write it in expanded form? Did you say 20 plus 5? If you did, you're absolutely correct. Well, what about the number 15? How do we expand it? That's right, 10 plus 5. And if you recall, we always create a box in order to do our work in for our partial products. As you can see, my box is a little larger this time, and it's because I need to have an area to multiply each of my numbers. So let's begin. First, we're going to multiply 10 times 20, and it's going to go in this box right here. So 10 times 20 is 200. Now, what do you think I'm going to multiply next? Did you say 10 times 5? If you did, you're absolutely right. Well, what is 10 times 5? Did you get 50? Great job. What do you think is going to happen next? Did anyone say multiply 5 times 20? Great job. 5 times 20 is 100. What do you think is going to go in that last box? That's right, 5 times 5. I like to think of it as the numbers that would run into each other and fall in a place. And that tells me which box we're going to be multiplying in. So 5 times 5 is 25. And so what I've highlighted for you are our partial products, because we took our problem and we broke it into pieces. And so now these are the individual small products that we came up with. What do you think we're going to do with these four numbers? Did anyone say add them together? If you did, you're absolutely correct. So we are going to add 20 plus 100 plus 50 plus 25. And when we do that, what do we get? Did you get 375? If you did, you're absolutely correct. Therefore, 25 times 15 equals 375. Great job, senior scholars. We'll do one more problem just like this tomorrow to prepare you for Challenge Day. Well, thank you so much for tuning in to Calendar Time with Ms. Whitfield. Miss Udo. I will see you tomorrow. Bye-bye.